Hello and welcome. We're really excited to have everyone here today for this OCI Observability and Management deep dive. For those of you who may be new to these events, they are hosted on Cloud Customer Connect, the Oracle Community Forums for end users. I'm Catherine Jennings, Senior Principal Product Manager for the O&M Central PM team, and we're joined today by Kumar Varun, Principal Product Manager, who's going to take us through the go-to-market topic of efficient estate management with Oracle Cloud Infrastructure, OCI Logging Analytics.
Thank you so much, Catherine. Welcome, everyone. So when you have tens of terabytes of logs coming in from multiple different deployment environments, multiple clouds, on-prem, what do? It's spread across multiple different tiers, as well as more than a handful of different teams: database administrators, application admin, DevOps team, system admins. Efficiency comes from usage of advanced analytics techniques that we have built in and provided out of the box from Logging Analytics. And that is going to be the main topic of tomorrow. How do we use this large volume of logs that are coming in, ingested, parsed, and use the machine learning and AI capabilities that we have provided in Logging Analytics to manage your entire cloud estate easily and efficiently? My name is Kumar Varun. I'm the product manager for Logging Analytics, and today I'm joined by Shriji Das, who is the analytics expert in our engineering team. So, as Catherine was saying, I'll cover a brief overview of analytics. I see a lot of familiar names in the attendees today, so welcome back. I'll talk about the top use cases, then give you some overview of, you may have known about that before, of how you can start using Logging Analytics, some basic things, and then we'll see how anomalies can be identified, outliers can be identified in real life, because that's where the core of all Logging Analytics advanced capabilities is. So just to start from the basics, we have the core infrastructure services, which are generating telemetry, compute, storage, network. And then on OCI, we have foundational services, which are logging, alarm traces. And at the top layer, what you see are the advanced services: APM, stack monitoring, DB management, capacity planning, SQL insights, and Logging Analytics. And Logging Analytics is the main topic of today that we are talking about. So just to give you a brief overview of what Logging Analytics is, it's a fully managed SaaS service, which is agnostic of any deployment environment where your environment is. And we have a lot of inbuilt knowledge content, which allows you to easily ingest, parse, enrich, and analyze. Now, what do you expect from a log analytics service? The first and foremost thing is the reliable collection pipeline that we have provided. We have provided an out-of-the-box methods for if you want to use UI, if you want to use SDK or APIs, you can rely on that pipeline. That data will always be collected at lowest latency, coming in enriched so that it's available to you for analysis. On top of that, we have executive grade visualization, interactive analytics for ad hoc analytics and troubleshooting, root cause analysis, and dashboarding so that you can monitor and present your analysis and results to your management, for your teams, for decision making. There are a lot of out-of-the-box dashboards and alarms and analytic capabilities which are available. And finally, all of this is powered by a sophisticated query language and curated AI and ML techniques, which is the main topic of today. Now, what is this complex environment? Now, every environment is different, but I thought it will be a good idea to show you one of the reference architectures that we have on Architecture Center today. This is a multi-cloud architecture where this application or this environment is based upon 3 cloud: OCI, AWS, GCP, and there are production databases, multiple different regions. There is dedicated connectivity using Fast Connect, and it makes the entire environment so complex that the networking, the usage, what changes are being made, and are the applications running at acceptable performance or not, that becomes a key challenge. Now, this is just an example. Your environment could be very different, and there are on-prem components also. So all the logs which are generated from these applications, from these infrastructure, from different cloud services as well as your custom environments are getting aggregated and collected in logging analytics in one region or maybe in multiple regions. We have customers who are sending tens of terabytes of logs from their Kubernetes environment, from their custom ISV applications who are sending those logs. So how do you manage them? Now, one of the biggest thing that comes up in managing these cloud services and cloud environment is what changes are being made? Who is making those changes? Now, there is application part to it, but most of it is as organizations are transitioning to cloud, the changes in services, the configuration of those services has been a challenge. And we'll use that as an example today on how you can identify anomalous changes or do the change management, track the changes on what different changes were made in the configuration, let's say for a VCN network. Now, if we step back, here are the two very different sides of one is the EBS suite, where there are typical questions in our business critical applications that how many jobs are taking longer than usual. While on the Kubernetes side, which is a cloud native platform, you want to correlate Kubernetes services with OCI load balancer or the load balancer you want to optimize. So there are multiple types of use cases that we have. One is for regular troubleshooting, for operational use cases, and another one is long-term analysis. And logging analytics provides both type of use cases where you have the active data, which is stored in the active storage that is available for analysis, while you can store it for any longer period of time, 3 years to 5 years for optimization, compliance, and audit use cases. Now, these are just few examples to start with. And the way we have made it easier today to start using logging analytics is we have a lot of out of the box canned solutions where you can discover and and create a topology. So when you're dealing with multiple different teams, it's very important to get a context in place. Otherwise, it becomes challenging when an issue comes to identify who actually should be starting to look at it. And what happens at that time is we have all seen now calls. Dozens of people get into a call to identify what happens there, and it's an open meeting, kind of a big pit, if I may, and we try to identify the right team and then the right person who should be looking at it. But the context in terms of the business, how the applications are organized, that is inbuilt. That is, we have provided for example, EBS, we have discovery for PeopleSoft. Then the second part is that log data by its very basic property is unstructured. It has log data can be anything. And we have provided a lot of enrichment in terms of functional issues, problem labels, soon threat intelligence scoring, geolocation enrichment, which helps in the next step, which is the advanced analytics for troubleshooting. It's not just the basic descriptive analytics, but you want to know what is happening in terms of the right KPIs that you are extracting from your logs. And finally, you don't want to repeat yourself, and dashboards and alerts help you there. Now, here is an example of how we are ingesting logs, very basic architecture from that previous example. Say you have a third-party cloud environment or an on-premises environment, which you see on the left-hand side. So management agent is one way to start collecting. You can collect logs using functions, streaming, a service connector. We can collect logs from object storage by monitoring it. You can use Oracle Integration Cloud to collect logs from any SaaS or third party. We have REST API support coming up. So, and if you have streaming applications, we can collect the logs from the stream. So, and these are all solid, reliable pipelines to start getting logs into logging analytics. And from there, you can have ingest time alerts or query or scheduled alert, which you can use for notifications and alarms. Now, when I say we have canned solutions available, here is an example of an app. Now, why this is and why I'm calling this an example? Every environment, every business is unique, right? We are giving a reference point, a reference architecture or a solution playbook where, hey, you want to start using EBS monitoring. This is a one-click solution available in Marketplace, which will install everything from end to end, configure logging analytics, configure all the different types of resources you need on the OCI side, and you can evaluate that. And now we have that also available in GitHub, and the reference architecture on the Oracle Architecture Center provides details of what exactly it is doing. And you can take the GitHub repo and expand it to your own based upon your own configuration. And these are all Terraform based scripts, Terraform based applications that you can use to extend and configure and customize in your own environment. So here is an example of EBS. And I wanted to give you one example of what type of dashboards that we are providing with this application. So this is we provide 5 different dashboards for EBS. There is a top level overview, and there is an example of the topology, which is auto discovered. Enrichment, geolocation enrichment on the bottom right, where are your users accessing the applications from? What are the different business flow, tech stack? Now, another thing that we have recently introduced is the business checks. We are not just telling that, hey, this is the issue or these are the problem categories, but when you look into this dashboard, we are saying, hey, these are the business flows or specific business areas which are getting affected. I'm pointing to the table at the bottom, and we are saying, hey, here is a Moz article which is available, and you can go and follow the instructions in the Moz article to fix that issue. If not, you can file an SR directly from here, which will take you to Moz. And a big issue that we see is when you're filing an SR or any customer support request, getting the context right is the biggest thing, so that the turnaround time can be faster. And here from you get the right context, and the turnaround times get improved itself. Another example is Kubernetes monitoring, where we are providing a full end-to-end comprehensive monitoring for all your applications, whether you launch it today or in future, you just launch the Kubernetes monitoring solution and it's fire and forget. We collect all the logs, metrics, and object information regularly and provide sophisticated dashboards like this. And as I said, these dashboards are a starting point. We have a lot of others dashboards and queries which are provided and built by our field folks, other customers which are shared in GitHub, and you can use those to expand. Then another example which are simpler and which are most typical if you are just in OCI is, for example, IDCS monitoring, where you want to start collecting logs using a function. This is a reference example, and it can be any endpoint, any REST and API endpoint for that matter after this. So it takes a function, it pulls the IDCS and collect all the security and audit logs, and we have provided a couple of dashboards related to that. The simplest use case for ingestion pipeline is a service connector, where all the OCI services, so for example, you have WAF or load balancers, OCI load balancers, you can simply go to the add data flow in logging analytics and start collecting those logs. It creates the entire pipeline from load balancer or any other service to logging, to service connector, and to logging analytics, including all the entity creation and everything in between in 2 or 3 steps. A good example for that service connector based flow would be using OIC as a source and getting the OIC Gen 2 logs and metrics into a dashboard. Here is another example of a VCN flow logs dashboards, which we provide out of the box. If you have onboarded and start logging, in the dashboards for logging analytics, you can see this dashboard populated in exactly the same way. Here we have, and there are 2 dashboards which are offered in product by default, which is the VCN overview and VCN analysis, network analysis. Okay, time for a demo. Let me stop sharing. And how do you get started? Hope you can see my screen again.
Yes, we can.
Perfect. All right. So if you find logging analytics under observability and management, And when you go to Log Analytics, you see four of these top level pages. We have I am on Log Explorer here and Observability and Management, Log Explorer. We have Home, and Home is a customizable home page that you can create from different types of log data that is coming in, and you can customize it based upon your own requirements over there. Where we have dashboards and administration. Let's start with Log Explorer. When you come in here, this is the primary view that you see, and it's a busy view. So let me explain what's over here. So on the right-hand side, you see the time picker where you can select different time ranges. You can also select custom ones. We have the actions menu where you want to create a new troubleshooting session. You can open a save search, or you can even share your query URL with your colleagues to start to look at the same analysis view that you have been working on. On the left-hand side, I'll come back to the query bar, which is here at the top, but let me talk about the fields panel. So on the left-hand side, we have provided all the fields which are being extracted, and then you have the visualization panel where different types of visualization. For example, this is the first view. I can switch to a histogram-based view, which shows you the time-based view of how these different types of logs which are coming in. So in the last 60 minutes in my demo environment, I have close to 6 million log records coming in. Right. Now, the enrichments that I was talking about, let's start with something like this. On the left-hand side, I have a field label, and we have attached these labels. These are not coming from the log records, but our understanding of those, that, hey, I have action failed, and I can look at those trends. So when you're troubleshooting, the first thing that you want to do is remove the noise that you have. And some things which are like action succeeded or HTTP error or out of memory, you may not be interested in them at all. And that's where you start with a specific label or a specific problem priority. So when you're looking at, let's say, problem priority, we have problem priority also attached. And you can simply select two of these. And now you notice one other thing that happened here was, hey, I have a problem priority of medium low. And these type of visualizations are very tightly correlated with the query language. And now I think it's a good time to show the query language. So when you click on the query bar, so once you have experienced the interactive visualization or interactive analytics way of doing things, you go to query language to create more sophisticated queries. And here are a few examples of what a query language looks like. So you can directly run it from there. So very simple thing will be to, hey, I want to search for failed, and you just type failed, and it will show you all the log records where failed string is there, failed or error, failed and connection. Some common commands which get more sophisticated here are available, and all the syntax, etc., is highlighted. So we'll come back to the query later on. Now, when we are looking at specific log records, so let me expand the first one. So these are the different fields which are extracted. So as I was talking about the Kubernetes environment. In case of Kubernetes, all the logs get collected even for future pods and future different objects and CRDs that you create, right? And you can start by analyzing those based upon different Kubernetes objects name and Kubernetes metadata. Or there is another method that we have recently provided, is the issues visualization. Now, to use this, it's very important to have you narrowed down to a specific type of entity or specific type of log source. Now, when I was talking about entity, what I mean by is now clicking on the top left where we have the scope filter. Entity is essentially, so let me take an example of EBS. So this EBS environment was discovered automatically when I was ingesting, when I wanted to set up EBS. And at the top level, you have this EBS VM on-prem environment. You have different middleware, which are the different components which are available, the database layer and the compute layer. If there are additional components like network or load balancer or any other components from EBS itself, those can also be added on the fly. And this is how you can use the automatic discovery and enrichment to narrow down to a specific log record or specific entity of interest that you are trying to analyze right now. Now, let me start a new one. New. So when you look at these visualizations right now, what we are doing here is a single variable or single dimension analysis here. I'm counting the log records based upon the group by the log source. Now I can do that the same thing where I can replace it with a label that, hey, tell me what different types of. Now what you see is, hey, I have action failed and action succeeded. What is the distribution of that? So when I was showing the faceted view, it was showing the trend, while here what it is showing is the distribution of those. Now from here you can say, okay, right now this action failed is dominating everything, and looks like there are around 4.5 million log records which do not have any labels attached. And because they are regular logs, they are just informational. So I can click on the show problem logs only, and you see it says the problem priority is not equal to null. And now I'm seeing the distribution. Now, let's say you want to narrow down further into this, we can click on that and exclude from search. And here you see a different distribution by removing that. I have removed the action fails label. I have removed the problem priority as null label, and I'm showing this distribution of different types of labels. And the next level of complexity that comes up is, hey, I want to see these distributions or these problem labels in terms of their priority only. So I want to introduce another dimension also. So for example, I can now change it to a tree map and then attach the problem priority and apply. I can switch the sequence of those. So now what I'm looking at, I'm analyzing it across two dimensions where we are saying, hey, I have these are the low priority and which is HTTP error, let's say here, and I just want to ignore those. So I can again exclude those. And these are iterative steps that you take to narrow down to a specific area of interest or specific entity or specific log source. And from there, we have machine learning capabilities like cluster, which are available. So not all logs are parsed and properly, all the fields that you're interested in are extracted. So that's where this machine learning capabilities called clustering comes really handy, where irrespective of whether it has been parsed or not, it tries to group all of those log records into different clusters. So when we were seeing previously the distribution, it has grouped those in 6 clusters, and these are different types of different clusters and their samples which are being shown, and they're prioritized in a certain way where you see depending upon a type of or certain keywords which are present in those logs. So, and we see potential issues. In this case, all the 6 clusters have potential issues. Outliers, in this case, there are none, but just for the sake of completion, outliers are the things which happened only once in this time range. And there are 5 different ranges. Let me expand the time range to something bigger, and I will also remove, let me just keep it. So now when I'm looking at last 14 days, there are 11, or let it finish. All right. So now I'm looking at close to 800K log records here, which has problem priority not equal to not equal to null. And logging analytics has clustered them into 9 different groups or cluster, 9 potential issues and 8 trends. And trends are something where the shape of the logs in the last 14 days is same across two or multiple different multiple different log source types. So, or different groups, if I may. And in this case, for example, this specific log record, which has this shape, which is not that much interesting. Let me find. Well, in this case, it's not there, but there is another similar trend which has coming from this log. There was this record failed to start management agent, and management agent is failed to start. These are correlated in terms of the shape. And these are just the basic starting points where all what you can do. So essentially, what I wanted to introduce you in the beginning was how you can use logging analytics BI tool like capabilities to start analyzing without going too deep into the query language to start with, and it has a very quick start time. Now, let's come to the main part of the presentation where, hey, now when we are looking at such large volume of logs, how do you analyze and how do you find out outliers and anomalies? So, again, okay. Right. So let's come back to traditionally from statistical methods, IQR is one method which we, coming from high school, that you can use statistical analysis for such kind of outlier detection or outlier or statistical outliers if you want. But let's go back to our reference architecture. We have not seen any log data which is that much structured to use standard statistical techniques. When you start introducing multiple different dimensions and based upon log data, which is multidimensional, an anomaly or an outlier will not be dependent upon a single variable. It is highly unstructured. It requires different field extraction at the time of query itself. It's very sparse and it's big data and it's not always complete. Now, when you put all that thing in context in real life, that anomaly detection or identifying outliers is not a simple task. And that's where our machine learning capabilities come in. And today we are going to be looking now at OCI audit logs, where all the changes done to your services and infrastructure are being captured by and done by maybe dozens or hundreds of users in some cases. And who is doing what? Is somebody changing a security list or somebody updating or creating new VNICs? And that's just VCN. And that's the main topic that we want to start showing to you today. And at this time, I'll invite Shriji Das, who is our analytics experts and leads our development team for logging analytics, to show us in depth on how we can use logging analytics, advanced machine learning capabilities to parse through and sift through this large volume of data quickly. And maybe Catherine, we can do it.
Got it, Kumar. Thank you. They've shared with us what's most important in logging analytics and what they'd like to see in the future. But if you could, I'm launching this second poll that will cover what applications and cloud services you're using, as well as how do you use logs for troubleshooting today. Give it another second or two to people to respond. Appreciate your participation in these polls. And there are 2 questions, so just as a reminder. Okay, Kumar, I think we've got a good quorum here. I'm going to end the poll now.
Awesome. All right, Shriji, over to you.
Okay. So thank you, Catherine, for the introduction, and thanks, Kumar, for going through the details. Hello, everyone. My name is Sriji. So Kumar did talk about how to do anomaly detection in some of the logs. So as Kumar went through some of the screens, log analytics is a tool for big data analysis because logs tend to be really large in size, terabytes of data. So we will look at how do we do anomaly detection in that kind of big data. So it's useful if we pick a concrete use case and walk through the steps, which is what I'll try to do in this call. So you're seeing logs for the last 1 year. A common use case we have seen for many of the enterprise customers is having to manage large number of assets in the data center, and also managing all the changes in that with those assets. So you have people changing the network, changing the database settings, changing the firewall settings, and so on. So what is a good way to identify what has changed in your system, who made that change, when did that change happen, and is that change an anomaly? So generally, when you want to do this kind of analysis, you go through a series of steps. Usually, you will pick the data set you want to analyze, and then try to narrow down to the specific subset of that data. So you do that by selecting your data set. So in this case, I'm going to select the OCI audit logs because that has all the changes in OCI. So that's a log that we ingest. We have a parser out of the box. So you would select this data set, then you will try to narrow down to the changes that you're interested in. Then you use some analytics algorithm to try and visualize all these changes and identify some patterns, and then see if those patterns show any anomalies. So we started with just selecting the OCI audit logs, and this is what it shows. And there are about 635 million logs for the time period that we selected. So it's truly large data. So one of the things we would want to do is to reduce this data volume before we do this analysis. This is JSON data. So here, when you look at the structure, you can see there is a type. So type in OCI is the REST API that was used to make this change. And everything has a REST API. So in the end, this translates to some call that made a change. So what we will do is to pick a specific area. So if you look at here, you can see that logging analytics is the area because these APIs tend to be named com.oraclecloud.area. The type of the event. So we're going to narrow down to the specific type. And if you look at the data, we will see that there is something called state change. So the state change tend to have the current state and the previous state. So we'll pick up only those logs that actually had a state change. Like in this case, there was no state change. There was no update. So we will try to ignore these kind of logs. Okay. So I'm going to first search for the type field because I know that is the field that captures the API that we looked at. So these are all the fields we parsed from the audit logs. I simply clicked on the type field. Now it's going to go through the 635 million logs and show me all the types available. So these are all the changes that happened. And for this demo, I'm going to pick the network area. So all the changes that happened in the network area typically have com.oraclecloud.virtual network. So now you're seeing only virtual network. So we'll do a select all. And we have about 635 million logs, and these are all the different areas of virtual network that's getting updated. So I selected type, and now you can see the query changed. My original query was just log source equal to this, but now I have all of these types. So we went from 640 million logs to 4 million logs. So that's our first step. We wanted to reduce the amount of data we wanted to analyze. And we were able to filter, and we are now down to 4 million. Now, this includes all of the changes for the virtual network area, but not everything may be a change. So we did see that there was another field called state change. So we want to pick up only the things where there was a state change. The way to do that is to say, for this query, take all the results, and from those results, show only those where the current state and the previous states were not the same. So that means some change happened. And while I'm here, I'm also going to simplify this query. This type is a big list. Instead of that, we can say that just show me all of those that match this pattern. So you can use the UI, you can use the query language to do this filtering. So now the query says, get me all the logs from OCI audit logs, but from that, only those that type match this pattern, and percentage is a wild card. So it doesn't matter what's after this. And from those results, pick only those records where the current state and the previous states are not the same. Okay, so now we went from 640 million logs to 4 million logs to about 1,000 changes. So these are truly the changes we want to look at just for one area.
So let me quickly understand this, Sriji. So what you're saying is now from those 600 million, whatever odd records, we have had odd 1,000 events where somebody made changes to my virtual network in the last 1 year.
That's right. So it's a very specific set of changes that we are interested in.
Right.
Yeah. So this is the process of eliminating the noise because we want to focus on the actual changes that happen. So the next thing we want to do is to start analyzing the data, because we have done our filtering, cleaning up the data, right? And we will use what is called link analysis for that. Link is a tool that you can use to do analysis of all your log data. And it's very simplest state. Link is like a group by. So it's just saying group by log source. And in our case, we only have one log source. That's why it's showing one row. So I'm going to drag and drop type into the group by and click apply. So the query changed. It's saying link type. And at this point, you can see the results look different because this is equivalent of doing a group by of the type field. So what this is saying is there are 33 APIs that were fired for this filtered data, right? That is the virtual network area where there was no state change. These are the APIs that were fired. So this says
on the first row, you're saying the update security list was done 236 times. So we have split that across. And now we're looking at one dimension. What would be maybe the type of change that could be the next dimension I want to look at? Are these, what are these type of changes, or maybe user? How do you go to the next step?
Yeah, actually, that's a good point. So when we look at it, we are seeing 236, and the only thing we know is these are all the update security lists, and this is the very first update security list, the timestamp of the first record, and this was the last update security list. It doesn't really tell us anything more. So a good check for this data set would be to see who made this change. So what we'll do is we'll take the username.
So I'm guessing this is an iterative process on what you are analyzing at this time, that different fields are available. That could be type of change or what fields that we were showing earlier. Okay, so you added username to it. Oh, okay. So now you have on the first row, update security list done by this cryptic username, and then the different counts of those. Okay, and I see these are these cryptic usernames 70db and something. Why is that? And
yeah, so we did get some extra information with the second round. So we had only the type. Now we have the username, but the username is not really readable. You would also notice that our first row numbers change. That's because the original count, the 600 plus was for 200 plus was for all the users. Now we split it by user. But the user ID is not that readable, that's because we masked the users, and it's a masked ID that we are seeing here. So for this demo,
Make
it'd be
it
good to
somehow
have.
more readable.
Yeah. So in this case, it's not that readable. There are a couple of ways of doing it. So one way would be to take this ID, and let's say we know the actual user of this ID, then we'll say for this ID, here is the user we want to show. And then for this ID, here is the user we want to show. Obviously, it doesn't work if you have large number of records. So what we do is we create what is called a lookup. So I have created a lookup, and this lookup is called audit user mapping. And this lookup has two fields. One field is what you see here, username, and it's essentially a CSV file. So you can think of it as an Excel spreadsheet with two columns. One column is username, and the second column is the actual user we want to return. So now it went through all of those records, and for each user, it's returning the actual username. So this
Okay.
is
So now if I
hopefully
read
it's
this,
easier to read. Yes.
Gary and Walker made 166 com.oracle cloud virtual network update security list changes. It's still a mouthful. Can we do something about the type to make it more meaningful? I see very useful information, but still it's a bit of mouthful.
Yeah. So again, this is the kind of process we would want to do when we do some analytics. We start with raw data and then try to refine the data. So as you pointed out, this is a good candidate for further improvement, right? So when we look at this, we can see that they all have the same first part, com Oracle Cloud virtual network something. So this is redundant. So one option is we just take the last part and show only that. That's easier to read and understand. So the way to do that would be we can use one of these commands here. For instance, extract is a command where we can give a regular expression. So the regular expression would be everything up to the last dot. So maybe dot star dot, and then everything after that extract into a field. So we'll get just update private IP as a field. But for this example, we ship an out-of-the-box lookup. So this lookup documents some details about this type, like what is the name of the API call and what kind of change is it making. So again, just like the username lookup, all I did was to pass this lookup and provide the type and get back two things. One is called a change type and the other one is called a description. And I renamed those to change. So,
okay, that looks very interesting now. So that update security list is actually a change type update, which we have provided out of the box mapping. And Gary and Walker did that 166 times in August 8 and Feb 18. Okay, looks like we have prepared our data for some unsupervised machine learning analytics, right?
Yes. So we did go through the data cleaning and selection step, and at this point, you have what you would expect for the analysis. Now, there is one additional thing we want to do. Our original requirement was that we also wanted to see what state change was, and we didn't add that here. Right? So we do have what is the type of change, but not the exact change. So what we will do is we'll just go ahead and
the
add
one that you
also.
were looking at the JSON, the current and previous. Exactly. Okay.
Right. So one thing what we do is as the logs come in, we look at the state change and capture them into two different fields as JSON. Because the actual change is going to be different depending on the API you use. So you can see that in this particular case, the current state was empty. The previous state was this whole big JSON, and the current state is empty. That's because something got deleted. Right? So this gives us everything we need. And I'm just going to hide these because the JSON usually doesn't look pretty. It'll still be used for analysis, but it just won't show up in this UI. So we are now kind of done with our data selection. So we have all the changes that happened with some descriptive names. We know what kind of change it is. Is it select, insert, update, delete? And we know which user made this change and when did they make that change. So at this point, one option is we just look at the table. The table has a search feature. We can go through this and find out what changes happen. We can sort and so on. But obviously, it doesn't work well when you have large amount of data. So one thing we can do.
Can we visualize it? A picture is worth thousand words, right? We have the data. We know exactly Patty Miller removed security group 7 times, but this is just virtual network we are looking at. Is there a way to quickly visualize this?
Yeah, so we can visualize this. One challenge is that when you have huge amount of data, you can't visualize it properly because the UI is going to look so cluttered. But we have an option, the analytical option. So what we can do is to, let's say, take this dimension. I'm going to click on Analyze, click on Create Chart, and I'm going to cluster this field. So clustering reduces the amount of data we need to display. So in this case, I'm going to say pick change type, cluster the change type, and then put the results on the x-axis of my chart. So this is now going through all the values of change type, and that's a summary. So instead of looking through close to 1,000 entries in this table, we're just looking at the clustered results for change type.
So we have these many, so I'm guessing the size of the bubbles represent how many times these type of changes were done. Okay, great. So what about other fields that we extracted? How do we bring those in? I want to look at what changes were there.
Yeah, so that's a good next step we can do. As you mentioned, we can easily see from here that there are a lot of creates and lots of updates, slightly less deletes and lot less list. If we had lots of values, we will just use this color to make it easy to visualize. And the size, if we had another numerical dimension, we can use that to control the size of the bubbles. But as you said, the question is, what do this create indicate? Like what exactly was being created? That's not really clear from this chart. So what we will do is to, let's say, add the actual change to the y-axis.
All right, I see now on the y-axis we have update Phoenix, delete private IP, and what is that yellow bubble now, that giant one?
Okay, so in this case, we clustered all the results, and because it saw all the results, it found that there is an anomaly. And this is an anomaly because all of the other number of changes were really, really small, but it did find that there are a large number of updates. And with respect to rest of the data, that is an anomaly.
But these changes, whatever those anomalies are, we're looking at last 1 year of data, but these could have been done at different times. Can we bring in the time dimension somehow?
Yeah, actually, it's not just the time dimension. We can also bring in, for instance, the user ID.
Oh, okay. That will be even more useful. Who did that? And so anomalies with respect to multiple different dimensions.
Right. So let's say we want to see what kind of change was done, when was this change done, and we ran out of axes at this point. We have only x-axis and y-axis, but luckily we have the size and color. So we can say use the color to distinguish the type of change and the username. So in this case, it's the same analytical tool, but we did change to indicate what should go into the x-axis, what should go into the y-axis, and what else should go into this colored field. So at this point, we have a better handle on what are the anomalies.
Okay, so now we're looking at last 1 year of data, analyzed it across 4 dimensions, and now we see anomalies. And this is just VCN. So if I want to just look at anomalies, is there any sort of filter I can use quickly?
Yeah, so as you add more and more data, one challenge is that it becomes harder to know what is going on. So sometimes you just want to isolate a specific entry and then look at what changes happened. So one thing you could do is to select this filter. So you click on this gear icon and select the filter options and select the filters that you're interested in. In this case, let's
Right.
say I
This looks
want
like a
all
very
the
dense
anomalies.
view, and I can interactively filter down, and I have these anomalies only on subnet. And what happens when you hover on top of one? Okay, so now I have this anomaly in time, and it's based upon multiple different dimensions. When Carey and Walker made this change, and which was 120 times updating security list, and nobody ever does that, especially Gary never does that, and that's why it's an anomaly. And now I can use these filters to filter type of change, the user, or the change type.
Yes. So this shows you what anomalies are there. And as in this example, if you want to know why is update security list an anomaly, you can select just update security list. And that shows all of the update security lists and the ones that are anomalous. And it should be self-evident as to why these are anomalous.
Excellent. I think this is super powerful with few clicks and by narrowing down to the right data and then using that chart builder, we came down to anomalous data and using multiple different dimensions to identify anomalies. And this can be rerun any number of times. And we can put this in the dashboard also. Great. Thanks, Riji. Thanks so much for doing this demo for us today. This has been super, super helpful and powerful. I think this is just the beginning where we are looking at some demo data. So let me share some resources with you on where to go from here next. There are lots of labs, demos, as well as OU certifications which are available. We'll share these slides and for your reference there where you can go to get started, to look at the demos, to learn more, to go to documentation, look at the reference architecture. If you want to extend and customize it, you can build your own apps by forking the GitHub repos. And there is a OU certification available, which goes into details of all of these analytics and ingestion and configuration setup end to end in super detailed manner.
And thank you all for joining. Have a great rest of your day, everyone.